We have one last panel after these lightning rounds with two commissioners, one who's with a commissioner of an energy office and one with a commissioner of a public utility commission to talk about kind of what they've heard and what and sort of their views on how things are evolving and how they see the infrastructure package playing out. So, Aurora.
Thanks, Karen. So without further ado, I'm going to kick us off into our next three lightning rounds, starting with Ty Roberts, who is the VP of Networking Solutions at Itron. So kick it off, Ty, talking on consumer and energy services engagement.
Thank you. Can you guys hear me okay?
Yeah.
Mm-hmm. Perfect. Actually, can you still hear me when I'm away from that thing? Good? Well, first of all, it's wonderful to see all of you in 3 dimensions. That's very unusual for me, at least these days, and I want to thank the GridWise Alliance for inviting me to come out of my house and spend time with everybody in person. It's wonderful. I'm going to be brief, I promise, but I wanted to talk a little bit about the concept of distributed intelligence, which we've heard a little bit about in many sessions today, and in particular how that applies to the concept of consumer engagement. And the way we think about this at Itron, but I think generally across the industry, is it's a let's try this again. So what happened with AMI 1.0, as we call it these days, first generation of smart metering solutions were deployed. There was a lot of time and money invested by the industry as a whole. Certainly, Itron was part of that. Lots of people were, utilities, service providers, technology providers, to try to build the concept of a home area network ecosystem, where there would be this bridge between smart metering infrastructure, communicating data into the home, and enabling consumer insights in the home. And of course, it just didn't take off the way all of us hoped that it would, the way all of us invested in hoping that it would. So what we're really looking at is how we do that much better going forward in this AMI 2.0 landscape. So 2 of the biggest reasons why that concept just didn't work initially was, number one, you had to have, as a user, as a consumer at home, the concept was there's going to be a radio on the meter. It was primarily a Zigbee radio that was blurting out data into the home, into a dedicated device. So this was back in the days of buying a standalone device, single function, single purpose, typically fixed, not too dynamic, didn't change over time. That was challenge number 1. Challenge number 2 was really related, frankly, is the content just wasn't engaging. So it's interesting to see a graph of your 60-minute or 15-minute load profile data, but after a little while, even utility geeks like me stopped caring. So that was 2 fundamental reasons why the content wasn't engaging, it wasn't there, and the investment required of either utility or, even worse, the consumer to buy something dedicated to engage in this home area networking phenomenon was just too high. It was a barrier to entry. So of course that classically led to the mean time to drawer scenario, where after a couple of weeks or a month, maybe a month, this thing that was sitting on the kitchen counter for a small number of utility consumers got put into a drawer and eventually got a closet or in the garbage. And so what we don't want to do is that again. So what we're looking at sort of as an industry and where we see we can do better this next time around with AMI 2.0, with next generation technology, is trying to address those 2 challenges very specifically. So engaging content and lowering the bar for entry for consumers, not requiring them to make a big investment just to participate and get information from a smart metering solution. So one of the ways that we're doing this, I'll describe a little bit, not in much detail, what a smart meter does. So what happens in smart meters today, and there's absolutely some parallel with the previous presenters, is there's a sort of high-frequency data generation thing that's taking sample data, which those frequency of the samples has been increasing as generations of smart meter devices have sort of evolved over time. But it's absolutely true that all that data, tens of millions of measurements per second, has typically just gone into incrementing a 15-minute or a hourly value that gets eventually loaded up to the back office and turned into a demand or a consumption invoice. So not terribly sexy stuff, terribly important stuff, because this is the cash register of the utility. That still has to happen. But what we realized as meter vendors over the last 5-6 years is that the cost of compute capabilities, CPUs and memory, has come down to the point where we can actually retain that original function of the smart meter, which is the cash register, but using that high frequency data, be able to do something more with it. So what we've done is created this first function is still happening, but if we can create and have created the concept of an open software environment in that same device, the same meter, where that same high-frequency data that's just today being used to compute 5 or 15 or 60-minute interval data, we can actually expose that to applications that are written by whoever wants to write those applications, the utility, other service providers, the meter provider themselves, whatever, doesn't matter, provide access to that high-frequency data. There's so much more that you can do with that same asset, that same device. What we're doing is, so adding to that meter-to-cash function, is really two applications that this sort of open software architecture allows you to, that has access to this high-frequency data, lets you do is number one, turn that device into a low-voltage grid sensor, so that looking at that high-frequency data, there's absolutely things that we can detect in terms of emerging faults, in terms of safety issues, high impedance cases, for example, where there could be something heating up in the home, or sorry, on the meter set itself, or on the service coming in, that is a fire hazard. Looking at broken neutral connections, there's lots of different applications there, sort of from a grid-facing perspective. But at the same time, that same environment, using different kinds of applications, can be using that high-frequency data to create consumer-valued insights. So this is turning this one device that did one thing, meter to cash, that enables it to do three things now. Same thing, meter to cash, cash register, no problem. But also creating grid insights and the ability to create insights that consumers themselves can take advantage of. So I'd love to say that as an industry, we meter vendors are turning this device into a ×3 from a price perspective, because of these three amazing things, instead of just meter to cash. That's not true. I'd love it, but that's not the way it works. What we want to make sure is that we can provide this kind of a solution, this kind of capability in a ubiquitous fashion. So these devices have to cost as much as a smart meter costs. But the benefit is there's really these two new advantages to it. So what does that mean from a consumer engagement perspective first? Actually, the last thing I forgot to mention is, in addition to that sort of being able to leverage that data that's right now just being used to roll up billing determinants and thrown away, that high frequency data is adding pretty simple change, pretty obvious in retrospect, is a Wi-Fi radio to that meter. So that what that means now in terms of consumer benefit is if we're using a Wi-Fi radio and we have an open software environment that can run different communication protocols, different application protocols to engage consumers in the home, then we have a device that is using a radio that many people already have in their homes, Wi-Fi sort of home-based home area networking, or just Wi-Fi in the home. Lots of people have it. I think the other thing that we're seeing that's incredible, especially with the new Jobs and Infrastructure Bill, is with expanding broadband connectivity and with a real objective of expanding internet connectivity around the country. That feeds into this really well, because the concept of allowing as many consumers as possible, ultimately all of them, to participate equally is really a key facet of how we do this better in AMI 2.0. So no more need to buy a dedicated device by the consumer that's going to go in the drawer later. They can engage with new information and insights on their smartphone, on their tablet, with other devices in the home that are linked through their Wi-Fi bridge, doing that securely and safely. And then the other is really, as noted, making sure that that architecture and infrastructure is open so that different application providers who have wonderful ideas that I don't have today, or lots of, that the meter vendor providers do not have today, the ability to access the high-frequency data and create new and wonderful information with it. Early examples of that are sort of the classic that we're seeing now is service providers that are driving appliance health programs. So notifying consumers when they can detect that different appliances in the home are maybe needing service. Sort of home care applications where I want to be aware if my elderly parent or grandparent is following their daily routine or not, and if I need to be concerned about it as a homeowner and as a sort of a concerned family member. There's lots of different ideas for the application here. So more engaging content, engaging consumers where they are with devices that they have today, really at the core of this. And the last thing I'll share, just a few different sort of considerations that we think the industry itself needs to be thinking about, utilities especially. Number one, as mentioned, is openness. Obviously, I think very clearly, being able to enable application providers, whatever their stripe, whoever they are, to deploy applications on that device, to be able to access that data from the device, to publish that to a cloud application, or sorry, a cloud environment that the utilities themselves managing, and allowing others to access more higher frequency data than service providers are seeing today, and be able to do that ubiquitously, so that you have the option to provide a service to any consumer in your territory, and then you are able to leverage those devices as a grid sensor or a low voltage grid monitor wherever you are. Because I think one thing is absolutely true is that we don't know is what those applications will be 5, 10, 15 years from now, and where you'll need to deploy them, and where you're going to have the need to monitor grid conditions throughout your low voltage network. So you need to have that capability everywhere, and that's really the impetus behind this sort of technology step change. So with that, I will stop and see if there's any questions or invite questions from Gridwise.
I like to ask the audience. So think about a question. I'm actually going to kick off with one question with my privilege here of kind of being MC. You had mentioned a barrier is data access, and your pitch is we want open data access so that third parties and customers can do more with it. Can you talk a little bit about why there might be a barrier to data, and give a little potentially legitimacy to that? I mean, I've heard of privacy concerns, potentially security, but then also take your best stab at addressing that.
No, it's a great question. So I didn't say it, and I probably should have, because it shouldn't be assumed that it's de facto, but obviously, with these programs, consumer-facing programs, it's very much the concept of opting in. So our belief is that these meters of the future, AMI 2.0 devices, which are devices of today, frankly, that they will be used by the utility as grid sensors at your discretion, because that's your business, that's your operations. Obviously, consumers will need to and want to opt in to particular programs and leverage services that they choose. It's their data at the end of the day.
Great. Thank you so much. I had said I'd take audience questions. I'm sorry. We're running a little short on time, a little behind. Sorry here, but you should connect with Ty. Yeah, ask
right,
him
I'll be there.
Excellent. Thank you so much, Ty.
Thank you.
Yep.